All right, we are here on example 4, and this is going to be a real world problem. To calculate the height of a building, Joel walked 200 feet from the base of the building and used an inclinometer to measure the angle from his eye to the top of the building. If his eye level is at 6 feet, how tall is the building? So, if we look at this building, he's obviously 2 stories tall because there's 2 windows in front of him, but we'll ignore that for a second. So, if we look at this picture, it is the exact thing that we talked about in the last example. We have a side, we have an angle, and we're trying to find another side. So let's see what we have to do. First and foremost, we're going to write down our SOHCAHTOA. So let's go ahead and say SOHCAH. I'm going to write TOA right here. So we have 76, which is our angle that we're using. So in this case, that will be our theta. We have 200 feet. Where is that 200 feet? Well, it's not the hypotenuse. So that's going to be our adjacent side. So we're going to say that's going to be ADJ, adjacent. Now, D, where is D? Well, it's not the hypotenuse, and I can draw a line going across the triangle to D, which means that this is going to be our opposite side right here. Let's use that. Now, we have an opposite side and an adjacent side. Let's find out which trig function we need to use for this. Sine is opposite in hypotenuse, cosine is adjacent in hypotenuse, but tangent is opposite and adjacent. So let's use tangent here. We're just going to say tangent of theta equals opposite over adjacent. That's from the OA in TOA. Tangent. Now we have an actual measure for our theta. So we're going to say tangent of 76 equals our opposite, which is D, divided by our adjacent, which is 200. Now we just need to solve this out. We're going to multiply 200 on both sides. We will end up with 200 times tangent of 76 equals D, D being our opposite side of the triangle. Now, you may think, all right, well, I need to figure out tangent of 76. I'm going to go ahead and I'm going to look at my chart right here, but I'm going to notice none of the angle measures up here is 76. That is because these are the most common angles that are going to be used, but sometimes we get weird angles that are just not up here. When that happens, we must use our calculator, and at that moment, we actually don't mind if it's in a decimal version. Tangent of 76 is actually just a function, so we're going to use our calculators to find out what tangent of 76 is. We can go here to Desmos and type in tangent of 76. Just like that, we say tan and then brackets 76. And you see that it gives us this wonderful little decimal here. Now, it's important to note that you have to be in degrees when calculating these things. This is with any calculator that you use and you're using trig functions. You have two-ish options. You either have degrees or you have radians. Right now we're working in degrees, so we have to make sure our calculator is in degrees. In Desmos, we're going to go over to the settings, which is this little wrench over here, and we're going to click that. And notice at the bottom, it says it's in radians. That's not what we want. That changes our answer immensely. Notice right now it says 0.6867, blah, blah, blah. Now when we change it to degrees, it's 4.01. That is a huge difference. So let's use 4.01 and use that in our calculations. It's just going to be 200 times 4.01 equals D. 200 times 4.01.
The answer is 802.
Sweet. We get 802 equals D. So the side length, the opposite side of that triangle, is going to be 802 feet. So is that the length of the building? Well, no, because we forgot one little thing, and that he's 6 feet tall, and we're going from his eye level. So this is going to be 802 plus 6. That is his feetage. So the side of building, we'll say side, is going to equal 808. Now, the guided practice is not a real world problem, but it is the same type of problem that we've worked in the past two examples. Here we have an angle, we have a side, and we have another side that we're trying to find. So go ahead and give that a shot, writing out our SOHCAHTOA, and pause the video and then press play when you're ready. All right, I know that you actually paused the video, so we are going to start working on this now. First of all, we're going to write our SOHCAHTOA. See how often this comes in handy? Sorry, TOA. And we're going to label our triangle. First of all, 24 is our angle here, so what are we going to be working with? Well, we can write an arrow across the triangle to get to 11. So that's going to be our opposite side. X, on the other hand, is our hypotenuse. Everybody should be able to identify the hypotenuse right away. H. So what are we going to use? Opposite and hypotenuse. It looks like sine is our guy. So we're going to use blue and say sine of theta equals opposite over hypotenuse. Our opposite is 11, so that's going to be sine of 24 is going to equal opposite 11 over our hypotenuse x. All right. Now, remember last time we looked at our chart and sine of 24 does not come up here. So we're going to go ahead and just type this into our calculator. Let's pull up our trusty Desmos. Sine of 24. Sure that this is in brackets. Sine of 24. It's going to be 0.407. So let's use 0.407. Just making sure that this is still in degrees. And let's use 0.407. Look at that. 11 over x. Now, this is a perfect time that we can cross multiply. If you remember, any number is just over 1. So when we're cross multiplying here, we're just going to multiply those two, and then put them on opposite sides of the equal sign. So this is going to be 11 equals 0.407 x. And then we can just solve for x. 0.407 divided by 0.407. Asking Siri, this is going to be 27.047, and that's going to equal x. So our hypotenuse is going to have a side length of 27.047. Yep, and that's it.